Okay, as we start our vectors unit, you're going to find that there's a lot of vocabulary. So let's start out with a little introduction. Certain quantities in the real world, like force and velocity, involve both a magnitude and a direction. They have a specific amount, like how much force, but that force is also being applied in a particular direction. So we don't always use a single real number for some of these quantities. We use what we call a directed line segment or a vector. And a vector has an initial point where it starts and a terminal point. And I'm hoping you can see this arrow. The arrow is right by the terminal point because that is the direction that the vector's behavior is taking. Every vector has a magnitude or a length. It says here that it can be found using the distance formula. I like to think a little more simplistically that it can be found using the Pythagorean theorem. And I'll show you more about that in class. Two line segments that have the same magnitude and direction are equivalent. So if you look at the ones in the figure 6.12, they all start at different places and end at different places, but they are in fact the same length, and they're going in the same direction. They look a little bit parallel to me, so I think that makes some sense. So all those line segments that are equivalent to each other represent a vector. You can call the vector V in bold. And this is a little hard to see. I'm going to rewrite that. This PQ has an arrow over top of it. Some books do this with just half of a vector arrow to distinguish it from a ray, but lots of different textbooks show it different ways. A lot of times vectors are just shown by their lowercase bold, like the U or the V or the W. So here with U and V, we want to know, are they equivalent? Well, the easiest way to tell is by looking at their horizontal and vertical. Here our horizontal is 3 units and up 2 units. So the question is, how about vector V? It goes from 1 to 4, so that's 3. And it goes from 2 to 4 along the y-axis, so that's 2. And they are both going in the same direction, so they are equivalent. Now here's where they were talking about the distance formula. Well, what I like to do is think about that in terms of a square root, but in terms of a right triangle. Either one of these triangles is going to have the same hypotenuse, because when we do 3 squared plus 2 squared, we'll just call it c squared. That'll be 9 plus 4 is 13. So our magnitude is the square root of 13. So I don't feel the need to have you memorize the distance formula because you can use the Pythagorean theorem, which is the same thing, just rearranged. Now, when we look at the direction, they both have the same slope. They're going up 2 and to the right 3. So they do have the same direction. They are parallel, and they are equivalent. Now, in terms of the component form of a vector, we will hear these words very often. What is the component form of a vector? Well, first of all, the component form of a vector uses these very strange pointy brackets. And it represents the horizontal component and the vertical component. So in our last vector, that one that was 3, 2, we would represent that way. It has 3 in the horizontal direction and 2 in the vertical direction. So the coordinates, they call them v sub 1 and v sub 2, are the components of v. And if the initial point and the terminal point lie at the origin, then the vector really doesn't go anywhere. And that's the 0 vector. And we can denote that by 0, 0 in the pointy brackets. So the component form of the vector, and I'll show you guys this in class, but what's very easy to remember is the component form is terminal minus initial. So we take the terminal point, subtract the x terminal point by the x initial point, and take the y terminal point and subtract the y initial point. So here you're going to see terminal minus initial. And the magnitude, again, is just the Pythagorean theorem of that. Now, some more, let me scroll down here just a little bit. Some more vocabulary. If the magnitude is 1, then it's called a unit vector. And magnitude can get denoted with 2 bars or with 1 bar. Different textbooks, again, do it differently. But a lot of textbooks prefer this way because then it doesn't look like an absolute value. So you can say that 2 vectors are equal if they have the same component form. That kind of makes sense, just like our 2. They both were 3, 2. So they were equal. They had equal components. And again, here is the initial point. And here is the terminal point. And in order to find the components, we're doing terminal minus initial. And then to find the magnitude, we take those components and apply the Pythagorean theorem. In class, we'll learn how to find the direction angle, but I want to wait and show that to you myself. So this is just to get you started for class, and we will pick up there.